Okay, in this video what we're going to do is introduce you to the if statement. The if statement allows us to introduce decision making into our programs. Very, very powerful stuff. Let's go ahead and block out in flowchart form a very simple decision. Let's say that I was coming through some code and I had an expression that was x equals 5. That means we have a variable x and we have just assigned the literal value 5 to it. Now let's say for whatever reason we needed to come in here and check the value of x. So we can come in here and we can say, is x greater than 5? If the answer is yes, see, here comes that branching that I was talking about just a minute ago. Then let's come over here and do something. So do something, right? And if the answer is no, we're going to make this a very simple if statement. Let's just continue on. So after we do something, we join back in to the execution and continue. And so this will execute no matter what. So I'm just going to say, that's going to stand for my right line. Okay, so right line executes no matter what. And we just continue on to the end of the program. There we go. There's a very, very simple example of us needing to check something and branching to another section of code if the condition is true. So right now, if we were to follow this through, x starts out as being 5, so we come down here. If x is greater than 5, well, it's not greater than 5, so we would not branch. We would just continue with execution along this path here. But let's say I came back up here and made x 15. Now, is 15 greater than 5? Yes. So guess what happens? Now we come in here and we branch this way. And we perform this code over here. Then we join back in with our regular execution. Okay, so we were able to branch away, perform something, and then continue on from there. So, straightforward, Logan?
Yeah, very straightforward. Just a way to conditionally execute statements.
So let's take a look at the basic syntax of the basic if statement. And I'm saying the basic if statement because if statement comes in different flavors. We have a simple if statement with only one line to be executed if the test condition evaluates to true. We have an if-else statement where we can do one thing if it's true or something else if it's false. We have multi-line if and else statements. We have nested if statements. We have else if statements. As you can see, there's a lot of different flavors here. So let's start out with the syntax for the most simplistic if statement. If. That's how it all starts. You must have an open parentheses. Within this open parentheses, you will have to have some sort of test or something that is going to be evaluated to a Boolean. Okay, that's the key thing here. So if, then there's our test, so our closing parentheses. Now, code to be executed if, here's the key word, the test is true. That's the key. And then we'll just butt right back up over here, and this code will always execute. And then we just continue on and on, like such. So, as execution is coming through, we hit this if statement. This expression is evaluated to a true or false. So that's our test. Evaluates to a true or false. If it is true, this indented line that you see right here gets executed. After it executes, execution then continues as shown here. If the expression evaluates to a false, we simply skip over that and continue with execution. Were you wanting to say something, Logan?
No, that makes sense.
Okay. So with this right here, we could do something really simple. Our little demonstration that we had over here, this guy, we could do something like int x equals 15. Then we could turn around and say if, here comes our expression, x is greater than 5, then we can say console dot right line greater than 5. You guys like my writing, don't you? Terminator. Then I can come back over here and say console right line always executes. That'll work. Okay? So once again, this right here is showing us this guy in operation using this simple syntax demonstrated above. So we come through, the first thing that's going to happen is we're going to declare the variable x and we will initialize it with the value 15. We then come down here and we do a check. Is the contents of x greater than 5? The answer is true, so now we're going to do this one indented line of code. That's the key thing. One line. That is all. If we want multiple lines to execute, we have to block them with blocking braces, and we'll look at that in just a minute. Once we do this one line, then we fall through and continue execution. Well, let me not use the term fall through because that could be confusing. We then just continue with execution. There we go. I like that. So Logan, this simple example. Let's set that up over inside of Visual Studio.
Okay. Inside of Visual Studio, let's start a new console application. So we have a simple test bed.
Okay.
Let's declare an integer. Call it x.
X equals 5. Or 15. 5. No, 15. I'm sorry. We'll stick with my little app.
Okay. So we'll declare x and we'll initialize it to 15.
Okay.
Now we'll begin our check. We'll say if. Then we'll do an opening parenthesis. And we'll say if x is greater than 5, console.writeLine
x is greater than 5.
Than 5. Okay.
Okay, now let's go ahead and right there we'll add console.writeLine always executes no matter what.
Always.
Do you guys like how I gave Logan an entire book to type in there?
No matter what.
All right, so right now well, go ahead and throw a read line in there for me just so we can halt execution. All right, beautiful. So looking at this, before we execute it, what's going to happen? Again, we're declaring the variable x, we're initializing it to 15, and then we're coming in here and we're checking. Here's our expression. Is 15 greater than 5? This is, remember, the relational operator that we talked about earlier, the greater than one. So all of our relational operators basically evaluate to a Boolean value, true or false. So is x greater than 5? Is 15 greater than 5? The answer is true. So this line really evaluates to if, open parentheses, true, close parentheses. If it is true, then we're going to do this line of code right here. After that line of code, we then continue on with performing this line and then this line. So what we should see printed out is going to be x is greater than 5, always executes no matter what. Let's go ahead and run this. And there you go. X is greater than 5, always executes no matter what. Let's go ahead and close that. Now, if you would be so kind as to set the declaration, or excuse me, initialization of x to 5. Now when it gets to if x is greater than 5, is 5 greater than 5? No. So the result that we should see on the console is simply going to be always executes no matter what, because this line right here, basically this was a false. So if false, well, it's not true, so we have to skip this line. And, well, there is no else, so we just simply continue with execution. So, again, what we're going to see is always executes no matter what. Go ahead and run that. What do you know? Always executes no matter what. Now, Logan, if you'd be so kind, close that out and put a breakpoint on the int x equals 5. And let's step through this and show them how it's jumping over that section of code.
Okay.
And make sure you tell them the hotkeys you're hitting.
All right, I hit F5 F9. Actually, I think I just clicked off on the side. Let me stop execution as I was getting happy with hotkeys. To set breakpoints, you can either click on the line outside in the margin, or with that line currently under the cursor, you can hit F9 to toggle breakpoints.
Okay, and then you're going to go in there and hit F5. Now, program execution has begun, and we, of course, stopped right there at the very first line because that's our entry point into the main method, and it's our first line of code. So right now, X has nothing in it, as you can see here. So once Logan progresses to the next line, you'll see that X is going to contain the value 5. In fact, if you look down here in our locals, X is currently set to 0. So let's go ahead and step.
All right, so hit F10 to step over.
All right, so now you can see X contains the value of 5, and we are now looking at this guy right here. So let's go ahead and see what we get when we step again. Look at that. Since it was false, we jumped right over this line of code, and we just continue execution. So you actually got to see it right there. Now, let's go ahead and stop the debugger. Let's change that back to a 15. And let's go ahead and hit F5 again. And once again, you'll see we're sitting here on this line. We're ready to execute it. Down here, X is currently at 0. Let's go ahead and step. All right, so here we are. We're ready to test. And we're looking at, is 15 greater than 5? So let's step. Look at that. This time, our path is different. We've branched into this section of code right here, which is just one line. But still, it is a different result than what we had just a second ago. So now we're going to write out X is greater than 5 because X is indeed greater than 5. So go ahead and finish off execution. And then it goes back out to here. And then finally to the end. And that's the end of it. So go ahead and stop the debugger. Very simple. So with that, we need to make things a little more interesting. So let's go ahead and jump back over to our whiteboard. And before I throw the else in there, anything else you want to add?
No, that all makes perfect sense.
All right, cool. So now I'm going to come over here and add a new sheet and hide this. And let's go ahead and draw out the same thing we had just a second ago. So let's say we set X is equal to 5. And then we come down and we do a check. So, is our X greater than 5? If yes, then we're going to do something, right? If no, we're going to do something. Then we're going to continue on. We're throwing in the ability to execute code if the condition evaluates to false. There we go. So again, we're doing something in there. So again, this allows us to do something specific if the expression evaluates to true. Otherwise, do something specific if it had evaluated to false. So this is where we get our else. So what does the syntax for this look like? Like such. If, open parentheses, test, and then I'll just put 2 comment marks in there. Do something here. Else, do something here, and then console.writeLine always. Okay, so that's what we're looking at. The only reason I'm throwing this is our basic syntax right here. And the only reason I'm throwing this into our syntax, because it's not really part of syntax, I'm just showing that that line's going to execute no matter what. But it's going to be really interesting because in a minute, Logan can show you how you can get in trouble with this if you're not paying close attention. Now let us take just a second and think about the formatting that we are employing here. This is so important. Notice how we have indented. Indented. Remember what I said when we talked about white space in the white space lesson? By doing this, we can quickly follow our code back up to the first guy that's not indented, and you could say that the code belongs to him. Okay? Just a way of figuratively speaking. Same thing up here. Follow this line of code back up to the first guy that's not indented. You could say that belongs to him. So now if we wanted to, if we were to take our little example over there and write it out, we could say if X is greater than 5, do something else, do something else, continue. And I'll just do that. So we continue. Okay? So Logan, if you would be so kind, let's go ahead and hop over to Visual Studio. And you can leave the int line there, but actually you can leave the whole thing there. Go ahead and break the, or turn off the breakpoint, and let's put an else in.
Okay. So yeah, like you said, we can leave this part of the if in, drop below it, and write out else.
Okay.
Drop down one more line and put some type of write line for the else condition. So we can do something like console.writeLine and say else or x is not greater than 5.
Yeah, x is not greater than 5.
Then 5.
Change that to then. Alright. Alright, so simple execution. Once again, we come through here, we declare the variable x, and we initialize it with 15. We then come down here to an if statement where we evaluate this expression. Is 15 greater than 5? The answer is true, so we do this line of code right here. Once we are done with that line of code, we then skip over and come down here and continue. Let's take a look at that over here on the whiteboard before this gets executed. So again, we come down, so here's our int, x equals 15. We do this line. We do this line where we're checking to see is 15 greater than 5. The answer is true. So now we do this line. After this line is done, since it is only a single line for the if, we then skip the else and its code and continue with execution like such. Okay? Let's go ahead and jump back over. Once again, I just wanted to draw that out. Alright, so with this in place, right now when Logan executes it, since the value 15 is greater than 5, true will be evaluated, and we're going to get x is greater than 5. We'll skip all of the else stuff, so then we're going to get always executes no matter what. So that's what we're going to see at the console. X is greater than 5, always executes no matter what. Let's try it out. X is greater than 5, always executes no matter what. Excellent. Let's go ahead and close it. Now, let's go ahead and jump back to the whiteboard real quick. And let's say that I change, so I'm going to take that out, this out, like such. And instead of this being a 15, let's go back to the example that we gave earlier. Let's initialize x to 5. So we initialize x to 5. We come down if 5 is greater than 5. Is 5 greater than 5? No. This evaluates to false, and because it evaluates to false, we do not do the true section of the if, we do the else section. So after we evaluate, we then come into here. Notice how this got skipped. So we come into here, we do this one line, and then after we do that one line, we just simply continue. Okay? So let's go ahead and jump back over into Visual Studio and demonstrate this. So now if he sets the 15 down to 5, what's going to happen is coming through. X is going to contain a 5. Is 5 greater than 5? The answer is no. We skip this line, so we come down to else, and we write out X is not greater than 5. Always executes no matter what, and we sit there waiting for you to hit enter. Okay, so let's go ahead and make sure we see X is not greater than 5, always executes no matter what. There it is. X is not greater than 5, always executes no matter what. Easy stuff. Very, very easy. Anything you want to add to this, Logan, before I start talking about the ability to perform multiple statements within a block?
Just possibly the danger of using a single line.
Fantastic. I'll turn this over to you. Let you talk for a minute.
Okay. Now you see we've visually indented the code after the code belonging to the if section and the code belonging to the else section. But it's not the indenting that associates it as far as the compiler is concerned. What associates this line of code with the else is just that that is the next statement that appears after else appears.
Right.
And same thing with the if. This is the next statement that appears after if appears. I mean, this could be written a variety of ways. You could do something like that, and that's perfectly valid. Where this can become dangerous is if you for some reason want to comment out this line of code just for testing purposes. You decide to remove it. So fair enough, that happens rather common if you just want to remove this line from the code for temporary reasons. The problem is we've just altered the way our code works, possibly without even realizing it.
Check this out. Actually, if I can throw in there real quick, because I can't help myself. Right now, it's going to look exactly like we expect it to look, because we commented that out, so we know we're not going to see X is not greater than 5, but we should see always executes no matter what with this current condition, right?
Right, that's what you'd think.
So, yeah, so go ahead and run it, and always executes no matter what. So it's like, yeah, so it's working. I got my line commented out. But now let's close that and change x back to 15. Now what you're expecting to see is x is greater than 5, and then the next line always executes no matter what. But what Logan's getting at is we're not going to see that always executes no matter what because it now belongs to the else. Show it. Look at that. We don't see it. It belongs to the else keyword.
So we've just broken our code. If we were expecting this statement to always execute, then we have a very odd condition on our hands, one that could potentially be tricky to track down because visually this still looks right. It looks like this comment belongs to the else, when in effect else is looking for the next statement. It'll look past this line return, it will look past this comment, and it will find this line. And now this line will belong to the else.
You got it. So let's go ahead and uncomment that. Very important to grasp, guys. And the indenting. Go ahead and take the right line, always executes no matter what. Tab that in. And then take out the space between the two. All right. That does not mean that those two lines are going to execute with the else only. Once again, in this particular case, since we're not using blocking braces, we are only allowed one line to execute if it's true, or only one line to execute if the expression evaluated to false. This will continue to execute no matter what. That is very important to understand. Proper formatting is very important. In this case, this is very confusing because going back to what I was talking about a few minutes ago, where we trace back up to find the first guy that's not indented, and then we say this belongs to him. In that case, it would be read wrong, wouldn't it? We'd follow this back up and say, these two consoles belong to else. No, it does not. This guy has been improperly formatted. So let's go ahead and pull him back out. There we go. Much better. Okay, so how do we get multiple lines in there? Well, let's go ahead and jump back over here to our whiteboard real quick. And let me bring up another sheet of paper. To get multiple lines, it's really going to be simple. We're just going to do the following. Here's your syntax. If test open curly brace code, as much code as you want. It could be just one line. It could be 20 lines. End curly brace. And then optionally, if you want it, else, open curly brace, code, closing curly brace. These are blocking curly braces. They block code. It's grouping all of this code together. So when you're using an if statement, and you're going to actually find that there are other statements as well, like while statements, for each statements, etc., where you have the ability to execute rather one line of code or a block of code. In this case, that's what we have. The if statement can execute if evaluation is found to be true. We can execute one line of code only or a block of code. You have to have blocking braces in order to have a block of code. You can't just indent a whole bunch of code and go, woohoo, we have a block of code. You do not have a block of code until you have these in place. Okay? Now, let's take this and look at it slightly different. I can come in here and do this. If test one line of code, else a whole bunch of code. That's completely valid, okay? Something you may see often. Now, as we code, and you guys follow along, you're going to find us putting even our single lines within blocking braces for the first couple of programs, just to get those of you that are completely new to working with a programming language comfortable with blocking in code, even if it is one line, okay?
Right, it just makes it harder to break your code than if you were to comment something or just start to visually align and visually block and visually tab things together.
Absolutely.
The braces will be, or the blocking braces will be your final block instead of just something that's purely visual.
Exactly. So you can see in this case, I am using formatting. So this is all tabbed in. First guy that's not indented that it belongs to, hey, it's this block right here, which is part of the else. Up here, this guy, first guy, he belongs right up under the if, so that's obviously what is executed if the expression evaluates to true. Again, even in my demonstrations over here through drawing, blocked to there, blocked to there. Formatting is so important. I can't stress it enough. So, Logan, with this, if you'd like, you want to go ahead and do just a very simple if and else example?
Sure.
That uses multiple lines. We can just do something real simple like just come in here and let's go ahead and just put some blocking braces in. Let's just block it to begin with and show that this code works just fine with our braces in place.
Okay. So I could drop in below the if, add a brace, and drop in right below we do the right line, and we have another brace, and you can see as soon as we write this closing brace in, Visual Studio highlights both that brace and the other brace it belongs to, so we can see already that this block is complete and put together correctly. Now we can do the same thing for else. Drop in one line below else, add a brace, drop in below the right line, add the closing brace, and then we have another block.
There you go. Now, this goes beyond the scope of this video here, but a lot of you out there might get on the internet and surf through other people's code. It is very common to see an open brace appear at the end of your test. So, Logan, you want to just demonstrate that?
Let's change these back.
Just a quick look. And then now after the else. All right. You may see this appear quite a bit. It's just one technique that many programmers have adopted. Okay? It just gets you one less line of code, if you will. But we're not going to follow this. We like lining everything up. Visually, it is easier to read, period. So Logan, go ahead and push those back down. And then what I want you to do is add another right line inside both of those so that we can demonstrate multiple lines of execution.
Okay. Let's do another console.writeLine and say this also belongs to the true block.
I like it. And let's copy that and put it down there with the false block.
Let me change is to this.
Okay.
Okay. Copy the entire line. We'll jump down to our else block, paste that inside of the block, and change this. This belongs to the. You want to say else or false?
Say false, because that's what's happening there.
So true versus false and all that.
Okay. So again, let's go ahead and take a quick peek at what we've got here. So x gets assigned 15. Is 15 greater than 5? The answer is true. So we step inside this block. We execute that line. We then execute this line right here. Then we hit the end of that block. That is the end of our true code. We're not going to do the false code. We're not going to do their else section. So we skip over. We come down here and we continue execution. Okay? So let's run it first and just show that it's going to print out x is greater than 5. This also belongs to the true block. Always executes no matter what. That's the 3 lines we're going to see. So let's go ahead and do it real quick. X is greater than 5. This always belongs to the true block. Excuse me. And always executes no matter what. Okay? Excuse me. Now, let's go ahead and, you hit a F9. Breakpoint. Yes. Me choking, that's all. Back to normal. Okay, so let's go ahead and walk through because I want them to actually see this through the debugger now.
Okay.
So he just hit F5, so here we are ready to initialize X, so go ahead and step. All right, X now contains 15. We're sitting here at the if statement, so we evaluate this to true, so we'll step. Yep, and here we are. Look at this. We're starting with our true block of code. So let's step, and now we're going to do the first line of the true block of code. Step. Second line of the true block of code, step. All right, now that concludes our true code. Watch as we skip over all of the else stuff. Ready? Go. Look at that. We skipped all over. And now we're down here, execute and execute. So go ahead and stop the debugger. Just to show the path different, let's go ahead and change that 15 to a 5. And let's go ahead and F5 again with the debugger. And here we go. So we're going to set 5 into X, step. We're back at the test. So is 5 greater than 5? No. So he's going to go ahead and step. Look at this. We're now starting the block of code that belongs to the else. Okay? Step. We do that. Step. That. Step. And now we're at the end of the block of code that belonged to the else, which occurred when our expression evaluated to false. Step. And this always executes no matter what. All right, very good. So let's go ahead and hit stop there. All right, let me jump back over here real quick. starting to cover quite a bit of stuff, huh, Logan?
Right, we've covered quite a bit of ground, and this is only if-else and blocking.
So now what I'd like for us to do is take a look at actually embedding ifs. So if we had, let me just bring this up. Let me show you what I'm talking about through a whiteboard. Be easier for some of you guys to visualize. So if I came in here and did something like if test then we're going to do something, and then maybe I want it to have another check inside this. If test, watch my formatting here. Do something, else, do something. Now I could even continue with doing something. And this is all going to happen right here if our first expression evaluates to true. Okay, so if it's true, then we're going to step inside our true block, execute. Now we're going to perform another test. With this test, if it's true, we're going to step inside its true block, do its stuff in there, and then skip over its else because we just did the true stuff, and then jumping over here, all the way down to there, we've finished the execution that belonged to the true block right there. And then we're done. And of course, if we wanted to, we could come down here and have an else, and we could continue on with another line of code if need be. This is known as nesting. So this right here is a nested if-else statement. Okay? It's nested if-else. Or some people just call it a nested if statement. Now, this is really handy if you need to check a value, and if that value is true, do a couple of things and check something else, and if that value is true also, do a couple more things. Very powerful stuff. So Logan, let me hand it back over to you, and then if we could just show a very simple example of where we're going to check, let's say, something like this, where we just check X. To see if X is greater than, since we've been using 5, maybe if it's greater than 5 and if it's less than 10. So we can embed that actually. Otherwise, just say that it's then less than or equal to 5.
Okay. And let's actually set this up in such a way where it starts building our X is text even before we get into the if. And then we'll just keep...
Actually, how about in this case, go ahead and delete all that if-else stuff. Just build it fresh.
Okay.
So we'll just leave the int in there. All right, so here we go.
Alright, to begin with, before we even get into an if, let's write down a line of code that just begins outputting text.
Okay.
So we'll do console, and instead of doing write line this time, I'm going to do just normal write, so we don't move on to a next line after this text is outputted. So we begin with X is space, and then I finish the quotes. And that way we have X is, and then we're waiting for some other text.
Okay, he's getting fancy here, guys. You'll see, though.
Alright, now after that, let's begin a check. Let's say if X is greater than 5, we'll start a block, and before I continue with the code inside this block, I'm actually going to jump down and finish the block.
Good.
So now we can jump inside this block, and we'll write something out. If X is greater than 5, then let's do a console.write, again, write instead of write line, and we'll say that, see, we've started X is, and then we'll just put greater than 5. Okay?
So we can test this right now. So if you start out and set, let's say set X to 15 again. So now since X is indeed greater than 5, what's going to happen is we're going to come down, initialize, then we're going to say X is, then we're going to do the test. Well, 15 is greater than 5. So since we didn't do write line, we did just write, our cursor is still waiting for us to append more text to the console right here. So now, since this is evaluated to true, we now continue. So X is greater than 5 because it's 15. Let's go ahead and run that. Look at that. X is greater than 5. Always executes no matter what. So we need to have a right line in there perhaps at the very end just to push everything down. We'll clean that up in just a second. All right, so let's go ahead and close that. Let's continue with this, though. So that's pretty good. So now let's find out if it's, we know it's greater than 5. Let's find out if it's greater than 5 but less than 10.
Okay, that means we need to do another check. So I'll begin another if. We'll say if x is less than 10, put in another block, because like we said, we're going to keep with the blocking even for simple code just for the time being.
Right.
And inside of this, we'll do a, excuse me.
So what happens when we talk for so long?
Dot right. And we'll write out.
Go ahead and bounce back up to the right and throw the R in there real quick.
Yeah.
Don't worry, guys. I'll catch him on that in just a second. And feel free to go ahead and clear your throat.
Okay.
And let me throw him some water, guys. All right. We don't want our programmer dying here.
All right. So we've got a one test, and then we write something out in that case, and then we've got another test. And we write something out if that test is also true, so for less than 10.
As I promised, guys, I told you I'd catch him. Go ahead and change that R and I around on right.
All right. Just waiting for the compiler to catch it and it hadn't yet.
All right, so there we go. So again, just to kind of review real quick. So coming down, X is, and now is X greater than 5? Yes, so we're going to write out greater than 5. Then we do this nested if. We're going to check now, X, is it less than 10? Well, it's 15. The answer is no. So if we change this 15 up there, change it to a 6 for me.
Okay.
So now with it being a 6, we're going to get X is greater than 5. Now, is X less than 6? Or, excuse me, 10? The answer is yes, because it's 6. So we're going to jump in here, and we're going to write out and less than 10. So now we're actually going to see X is greater than 5 and less than 10. But we want to make sure that we've got a space in here somewhere, so that, or a space before the and. Either way, just so that the sentences don't get thrown together in such a way that it just looks really bad. So let's go ahead and compile and execute this. And look at that. X is greater than 5 and less than 100. And don't worry about, we'll fix this butted up, always executes no matter what in just a minute. So very nice. Now let's go ahead and, actually we can fix that right now. Right after this if, check this out. We jump back into our first if statement. So we're now back into the code that executes if that very first X is greater than 5 is true. Let's just go ahead and do a simple console.write line with nothing in it.
So we'll do a write line. And I'm going to put nothing in for the argument so that we just get a line with nothing on it. Okay.
So let's go ahead and execute. And there you go. X is greater than 5 and less than 10. Next line. Always executes no matter what. Oh, that's beautiful. Looks great. All right, so now to finish this off, let's put an else for our primary if.
Okay, we'll drop down right after the primary if. We'll add an else. And again, we'll block this in before we continue. Then we'll jump inside of that block, and we'll say console.write line. And we'll feed it
less than or equal to 5. Because it could be equal to 5. All right. And in this particular case, notice how he did a write line because he's not planning to append additional text to it on the console. So that way we'll already have the new line in there for the always executes no matter what, so it doesn't get appended to the end of the other one. So with this in place, let's see. Let's go ahead and set X to 5.
Okay. X is set to 5.
And let's just run it real quick. X is less than or equal to 5. Okay, let's close it. Let's set X to 15 and run it. X is greater than 5. Always executes no matter what. Good. Okay, let's close that. Now set X to 8 and execute. X is greater than 5 and less than 10. Always executes no matter what. Now, if you don't mind, Logan, go ahead and close that out, and let's debug this just so that we can walk through it. So, yeah, go ahead and do that, and go ahead and execute. So here we go. We are now declaring and initializing. Let's step. We're going to write this out. Let's step over. Okay, now we're going to do our check. Is 8 greater than 5? The answer is yes, so we better step into our true area. So go ahead and step. So we're going to hit here. Good. Step. Aha, so now we're in our true area. So we're going to write out greater than 5, step. So now we're going to perform our nested if statement right here. So another check, which is 8. Is it less than 10? The answer is true, so we're going to come to right here, step, yep, and step, which means we're going to perform our true code. Here we are, yep. Okay, so we write out and less than 10, step. We're now at the end of this, step. Now we're going to finish the code because all of this belongs to this true block right here. Now, step, here we are. Now what we need to do is go ahead and let's just come over here and scroll down a little bit. Now, when Logan steps next, we're going to jump over all the else stuff and come down here. Go ahead, step. Look at that. Beautiful. And we finish it off. Go ahead and stop execution real quick. And I know just beating the subject to death, but hey, it doesn't hurt. You guys can always stop the video. And if you're a little bit confused, you can continue to watch. So with this, Logan, let's go ahead and set this to 18. So just put a 1 in there. Okay. And F5. All right, so here we go again. So we initialize. Go ahead and step. All right, we're going to write out X is. Go ahead. All right, now we're going to do our test. Is X greater than 5? It's an 18, so the answer is yes. So we're going to come here. So step. Now we're going to perform our true code. So go ahead. All right, so now we're going to write out greater than 5 because that's the case. Let's step. Now we're ready to perform our nested if statement. So is 18 less than 10? No. Watch this. Go ahead and step. We skipped all of this code because this is our true code. So we do this right line because, again, this still belongs to and must be executed if this expression evaluates to true. And step. Now we're at the end, and we're going to jump again. Let me just come over here and pull this down. We're going to jump right over our else. Let's step. Bink, and we finish it off. And now go ahead and stop, and we're going to do one last example so that they've seen it all. Go ahead and set X to a value of 2. And run one more time. So F5, here we go. So we initialize X to 2. Go ahead. All right, we're going to write out X is. Go ahead. So now is 2 greater than 5? The answer is no. And with that being the case, we're going to skip this whole block of code that is our true code, if you will. And we're going to start right here on the else code. So ready? Step. Look at that. And now we're going to perform our false code. Let's step in. Good. And so we do that line of code and then step. Here we are at the end of it. Now step, execution continues and finishes. There you go. We have walked through all 3 conditions and seen how the code branches around internally. Brilliant, brilliant stuff. All right, Logan. So with that, how about we give them another example that's going to be very close to an else if. So this will allow us to kind of work our way into the else if. And what I've kind of got in mind is how about we do some range checking, but we put it in the else, okay? So let's do something like, we'll set X to 5 to begin with, and we'll check to see if X is greater than 5, and if it is, we'll just write something else that says greater than 5. Otherwise, so our else, we'll immediately do another check that says if X is less than 5, then we'll just write out that it's less than 5, or we can say X is 5. So it's not going to be range checking. We're just going to find out if we're rather greater than 5, less than 5, or equal to 5. That's what I want.
Okay. So
did that make sense to you?
It did. We want to see, we're checking for 3 possible cases.
That's right.
We're checking, are we at exactly 5? Or rather, we're checking to see if we're greater than 5. And if we're not, we're going to check and see if we're less than 5. Right. If we're not less than 5, then we know we must be equal to 5 because we weren't greater and we weren't less than. Precisely.
So write that out. So this is going to have our nested if statement this time around within the else of our primary if statement.
Okay. I'll begin by stopping execution from our last test.
Okay.
I'll remove the breakpoint for now.
And let's just kill out, set that back to 5. And let's kill out all other code.
Okay.
Except for the final 2 consoles. Yeah. Okay, so let's do this.
All right, first check. Is X greater than 5?
Okay.
If it is, we'll start a block of code, and I can go ahead and jump into that and do a console.writeLine and say greater than 5.
All right.
Now we can jump below the block, put in an else,
and block this in. And now we're going to embed our if inside this else. So let's go ahead and start an if in here. So we know at this point that X is not greater than 5. So it's rather less than 5 or equal to 5. So let's use this if to find that out. So if X is less than 5,
then we'll begin a block, end that block. And before I even put the code in, let me go ahead and finish off the else for this one.
You bet.
So let me jump down, I'll put in the else, jump down again, and we'll have our open and closing braces for the block. I'll go ahead and jump inside both of those.
All right. So if x is less than 5, we can just simply say less than 5.
Console.WriteLine, and we'll say less than 5. And I'm going to just copy this line into the else.
Sure.
And inside of this, if it was not greater than 5 and was not less than 5, then x must be equal to 5. All right. And that should be looking good.
Okay. So with that in place, first of all, right now you've got x is 5, so we should get equal to 5. Let's go ahead and run this. Equal to 5. Always executes no matter what. Very good. All right, let's close that out. Go ahead and change x to 15. And let's do it. It's greater than 5. All right, now let's change it to 2. Less than 5. Woohoo, fantastic. Let's go ahead and close this and go ahead and set a breakpoint right there at the beginning. And now let's walk through it. I know this might be getting a little old, but again, very important concepts for you guys to grasp. So again, we are initializing x to 2, so let's step. Now, is 2 greater than 5? The answer is no, so we're going to start right down here at the beginning of our else. So let's step up. There we are. All right, so step into the first line of it where we're now going to perform another check. If x, which is 2, so if 2 is less than 5, is 2 less than 5? Yes. So we're going to start the true code. So step. Ooh, there we are. Step into it. And now we're going to perform this. So we're going to show less than 5. So let's go ahead and step. Now here we are at the end. Now before you step, let's pull this one down so you can see what happens. So now that we've done this, we do not need to do any more of, we don't need to do the else for this embedded if or nested if. So we're going to step all the way over here to the very end of this else. So let's go and step. So there we are. Let's go ahead and step again, and we perform and perform, and that's it. So let's go ahead and hit stop. And let's just do one more example. Instead of 2, let's set it to, I'll go ahead and set it to 12. All right, let's run. This is going to be an easy one. All right, so here we are. X set to 12, step to next line. All right, next line says, is 12 greater than 5? It sure is, so we're going to come right here to the true code. So step, we're at the true code. That means we're going to perform everything inside our blocking braces. Step. So we perform it, step. All of our code inside the blocking braces are done, so we're now at the very end. So what does that mean that's going to happen? We're simply going to skip all of the else and start right here. So now we're done with the whole if statement, and we continue on with execution like normal. But check this out. The way we're doing this in this particular case is we're saying if this condition, otherwise, if this condition, otherwise. What if, in this case, we just had 3 possibilities, whether it's greater than, less than, or equal to? But what if we had a scenario where it could be red, green, blue, black? We had a whole bunch of things. Do you really want to continue nesting if statements like this? That's going to look nasty really, really fast. So the answer is no. So we have an else if that we can use. So let me go ahead and jump back over here to the whiteboard real quick. Let me introduce you to the else if, and then let's go in there and recode that example that we just gave utilizing an else if. Okay? So I'll bring up my whiteboard because I like to. I'll give another sheet of paper. And here we go. What does the else if look like? Well, here's our syntax. If, again, we do a test. Now we're going to do a blocking brace, lines of code, closing that. Now you're used to seeing else, if. Ooh, I'm throwing something new in there. Open, our test, close, blocking brace. Check it out. I'm not indented. I'm still all the way out against the edge right here. Code. I can just keep doing this. Else, if, test, blocking braces, code, and then we can say our catch-all, else, and code. That's beautiful. Now we don't have all these crazy embedded if statements that could technically get deeper and deeper and deeper. Because we could just come in here and say, Is it red? Else. Is it blue? Else. If it's green? Else. Okay, it's some color other than all of those colors, right?
Right, and the nice thing here is that it progresses in a very nice linear fashion. It's adding another check is basically viewed as one more step, linearly. Whereas in the other case, if we keep nesting if statements, the if statement gets deeper and deeper and deeper and harder to debug.
More formatting, so now you get pushed over further and further and further off the screen. So yeah, harder to debug. This is much cleaner. So with this, Logan, let's go ahead and jump back over into Visual Studio. And how would this look? Yeah, we can go ahead and stop the debugger. If you rewrote it to use the else if.
Okay. Do you want to completely rewrite it or just
Well, no, we
modify
can just change it right here. Watch this. He's just going to modify it.
All right. Well, we know, let's see, we want to catch all. So let me do some changes. Let's make this an else if some condition. We'll do our x is less than 5 check at this level.
Okay.
We take the code out of this if block and just paste it in right below the else if.
Okay.
We don't need this block at all. I'm going to take the final else, cut it out of the else if block, move one line down, and paste it in outside.
Ooh, it's like magic. He just rearranged the cards.
So we still have all the code for our else, which means it's equal to 5. But in this case, everything is done what looks like, or what is, at the same level. So we do a check. Otherwise, if that's false, we do another check. Otherwise, we do something in case none of these came up as true.
All right, so let's go ahead and make sure it runs. So right now you've got 12, so let's see what 12 is compared to 5. So execute. Well, 12 is greater than 5. Okay, so now change it to a 5. And, well, it's equal to 5. Very good. And let's go ahead and change it to a 2. And less than 5. Beautiful. But watch. Here's where the power of using the else if comes in. Let's change the relational operator greater than to the equality operator. And let's check for values 3, 4, 5, 6.
Okay. So you want to begin with checking for 3.
Okay.
Then you want to do a check for 4. And then I'm going to copy this entire else if block.
Mm-hmm.
And then I'm going to put the cursor right at the level of the else and hit paste. So that gives us 3, 4, and this 5.
5 and 6.
So in this case, I'll just paste again. So we have these. Now I can just put in the values. So we have 3, 4,
5, 6. Now let's start with the first right line and just say...
I'm going to copy the equal to so I don't have to retype it.
Okay, cool.
So paste with the first. We're checking for 3, so we need to put equal to 3.
Okay.
And then equal to 4. And this should be the same, equal to 5, and it's already 5. Then finally equal to 6.
And then for the last right line, just say some number other than 3, 4, 5, or 6.
Other than 3, 4, 5. Do I say or 6? Or
either way, it doesn't matter. Just 6.
Yeah.
There you go. That works. Okay, so very simple. You can see we didn't have to go nesting like crazy with a whole bunch of ifs. This is very easy to read. We're simply going to come in and we're going to, well, our first one's going to be a great example because it should be caught by our catch-all down here with else. But x is set to 2. And here's how it's going to run through. Is x equal to 3? Nope. Is it equal to 4? Nope. Is it equal to 5? Nope. Is it equal to 6? Nope. All right. It's some other number than 3, 4, 5, 6. Let's go ahead and run that. Some number other than 3, 4, 5, 6. Let's go ahead and close. All right, set it to 4. So we should get picked up by equal to 4. Let's go ahead and run it. Equal to 4. Close that. And let's go ahead and set it to 5. And it's equal to 5. So you guys can see this is working just fine. So else if, very handy when you need to start doing multiple checks. And there's no reason to really start doing a bunch of embedding.
Right, it makes it a lot easier. Like we were showing just a second ago, every time I wanted another check, it was simply another step where we took one of the else if blocks and just made another one.
You got it.
Now, there is one thing I do want to point out in this case, and that is what would happen if more than one of these checks were potentially true.
Okay.
What would happen, like, let's change this one. Let's pick on the 4. Let's say if x is greater than 4 and then leave x5, because what's going to happen? Which of these are true? Well, this one is going to be true. 5 is greater than 4. This one is also, or would also be true, because it's equal to 5. So what's actually going to happen here?
Okay.
Let's run and see what the output is, because, I mean, there's two possibilities. Either we only get 4, or we get 4 and the equal to 5 line. So let's see which one it is. Equal to 4. And this line did not get executed. That's because the way an else if works is if any of these are true, we do that block of code and then jump completely out.
Because we are now done with the if statement.
Right, so the if else will do precisely one of the blocks. If any one of them is true, then all of the others are skipped.
Now, if you need the ability to do what Logan was just demonstrating, make sure you join us in the next video when we talk about switching, because then we can introduce stuff like that. All right, so pretty good. I think this covers all of our if stuff. How about we revisit operators for a few minutes?
Okay.
Sound good to you? Okay, so let's go ahead and jump over here to the whiteboard, and let's bring up another piece of paper. And the only reason we're doing this is because I promised that I would come back to it, and I think now is a really good time to come back to it. So what we're going to do is talk about just a couple logical operators, and this will give us a lot more power when we're doing a test. And in that test, we need to actually check a couple of different things. Like, what if we needed to do an if statement where we needed to check to see, for example, let me put this up, if x is equal to 4 and y is equal to 16, just as an example. Okay? Well, how could we put this into an if statement? Well, simple. What we would need to do is use a logical operator, and we would use 2 ampersigns like this. This stands for AND. Now, while I don't want to get into a lecture about short-circuiting right now, you could use that or just a single ampersand. The double ampersand allows for short-circuiting, and in essence what that means is if we're evaluating this, and let's say x is not equal to 4, we're going to short circuit out. There's no reason for us to finish testing everything else, because right now using the double ampersigns right here, basically what it's saying is both of these have to be true, both of these expressions. If they are both true, then our final result for our if statement, check it out, is true. But by using the double ampersigns, and what it's going to do is simply right here, if x came in as something other than 4, this is false, it stops. It never even checks this. If we had used the single ampersand right there, then what would happen is it would check this and this no matter what. And in this particular case, there's no reason for us to check both sides. But let's say we were calling methods that return values and we needed both methods to execute. Then perhaps we wouldn't want to do a short circuit because, like I just said, both must execute. But that's a little bit more sophisticated, and we'll visit that a little bit later. So I just wanted to mention that just in case you had seen the use of a single logical AND before. All right, so here we are with a logical AND, and we have our true code. Everything else continues like normal. This simply allows us to say if this is true and this is true, then the whole result is true. And remember, in the end, what's the if looking for? A single true or false. So Logan, if you want to just find something, make something up real quick that you can use our double ands for, just to show them a logical AND operator.
We could even show the one that was drawn and then modify it to make something.
Sure, have some fun here.
All right, I'm going to take out our if-else that we've got currently. And just to mimic the whiteboard, I'm going to throw down a y variable initialized to, I forget, what did you have, 16?
Yeah.
So I have x equal to 4, y equal to 16, and then we'll begin our check. Where we say if x is equal to 4, and y is equal to 16, then we want to execute this block of code, or we could just say something simple like console.writeLine. Do you want to put in 4 and 16, or just both expressions are true?
Just, yeah, say both are true. That'll work for me. Okay, and execute. Okay, so both are true. Now go ahead and close that, and this is kind of important to me. I like putting all of these tests in their own parentheses. It makes readability easier. You saw that everything executed just fine without doing that. This simplifies readability. Don't you think, Logan?
If you're going to do that, I would also go so far as to space off of the final outer parentheses for the if. So we can look at this by itself, look at this by itself, but then if we highlight the edges, we still see that all of that belongs inside of the if.
And now to demonstrate, now go ahead and run, show them it works just fine. So both are true. Now go ahead and change the double and to a single and just to show them that they're going to get the same thing. And both are true. So you get the same thing, but both expressions were evaluated, not efficient in this case.
Right, but and the other key, the reason why this doesn't look different is we're not doing anything, or these expressions cause no change to anything.
That's
right.
They
just do a check.
Exactly.
So as far as we're concerned, either one has the same visible effect.
Exactly, except for in regards to what's most efficient, in this case, the double would be. We want to short circuit out.
Again, because nothing happens. If we, from this check, know that we're going to have false, there's no reason to go on and check anything else.
You got it. Okay, very nice. Now let's go ahead and set one of those to false. Let's go ahead and set x to 44. All right, so now let's run it. Always executes no matter what, because we don't have an else in there to catch a false part of it, which is fine. But you can see that what's happening right here is when we come in, this very first one is 44 equal, see, the equality operator. So is 44 equal to 4? No. We don't even check over here because we have this AND operator right here. So the answer is no. We skip over, we come down here, and we just say always executes no matter what. End of story. Even though our Y is still true. That brings us to the next logical operator that you may find yourself in need of. And that is, instead of an AND, what if you wanted to do if x is equal to 4 or y is equal to 16? See, I like drawing it that way. It's so much easier to see. And then, of course, that is part of the if. Okay, so and then again we can have our blocking braces. Those are blocking braces, I promise. And then code to happen. So this is OR. How does OR work? Well, if this is true or this is true. Okay, in that particular case. Now we are using the double pipe symbol, so we will short circuit, meaning if this very first one is true, we don't need to check the second one because, well, our condition's met. It's either or being true. So with that being the case, we can go ahead and jump out and do our true code because the whole thing will evaluate to true. Again, there is just a single that we could use if we need to make sure that both of these sides are fully evaluated. Again, we're not going to be doing that right now. So Logan, if you take just a moment and jump back over there and change that to an OR instead of an AND.
Okay, and we could leave x44 now just because last time we knew that this didn't execute because we had broken the AND.
Yep.
Let's see what would happen if this was run as an OR.
And what you're going to see is it's going to come in here and say, is x equal to 4? No, but since it's an OR, it's going to continue evaluating. Okay, is y equal to 16? Yes. So the whole thing will be yes or true. And there you go. Both are true. Always executes no matter what.
The text
well, not both. Hang on. Yeah, that's just
so
me. There
one is true. One
or both are true.
That's a good point. One or both are true.
Is true.
Talking is fun.
Yes, it is. Okay, so there we go. Now we'll go ahead and run it. We can redeem ourselves. One or both are true. Yay! All right, very good. Close that out. So that is an OR. And you can embed these. You can do some crazy stuff with it. Now, what if you end up in a situation where you don't need to logically check if this and this is true, or this or that is true? But what if you need a situation where only one can be true? Rather, this can be true, or this can be true, but both cannot be true. It's another logical situation. And this is where you would use an exclusive OR. Wow, it just keeps getting better and better. An exclusive OR. So with an exclusive OR, you know what? I'm just going to use my OR code. Well, I won't even do that. I'll just simply do this. So for an XOR, so that's what it is. It's a logical XOR or exclusive OR. We simply use the caret. So one of these must be true, but not both. And that will result in a true statement for us. You want to demonstrate, Logan?
Sure. If we jump back into the code and we change the OR to an XOR with caret symbol.
So in this case is 40, or see, X is 44, so it's 44. Yeah, and just the one is true works there. So X being 40, so it's 44 equal to 4? No. Okay. Exclusive for. So is 16 equal to 16? Yes. Beautiful. Let's go ahead and run this. So we get a true out of it, and 1 is true.
And only 1.
So let's close that. Now let's go ahead and set X to 4 and leave Y at 16. So now we have 2 trues. Let's go ahead and run it. Look at that. Even though both of our statements within were true, because we were using an exclusive OR operator, we get, well, in this particular case, an evaluation to false, because only 1 can be true. And some of you might be thinking, why would I want to use something like this? We promise later on, as you get slicker and slicker with logic, you're going to need stuff like this. All right, so Logan, I think that's going to about wrap it up. I think we'll introduce the negation operator a little bit later, unless you want to throw something out there quickly.
We could. I think it's best left to later.
Yeah, because there's a couple of things I want to do with it. So, guys, you're listening to us actually discuss how we want to present this. At this point, this is everything that I wanted to throw out at you and a little bit more. So this is going to wrap up the video. We've set out and accomplished what the plan was, which was to introduce you to the simple if statement, to introduce you to a simple if-else statement, to introduce you to having multiple blocked lines of code executed if your statement is true or else if it's not. And then we've also talked about nesting if statements. Let's see, what else have we talked about? We also talked about the else-if statement, and then we took a look at logical operators, which was something in the expressions and operators video we promised that we would come back and visit, and we have now visited it. Hopefully you see that, now I see why he wanted to demonstrate these logical operators with us understanding how the if statement works, because it makes it so much clearer. So with that, now you are armed and dangerous. You know how to add intelligence into your applications. So with that, that is going to wrap up this video. Thanks a lot.